Today's problems count the number of possible triangles. The difficulty is medium. Accuracy is very low, actually, in the 20s. Average time is low, 15 minutes. It's interesting. It's like people knew how to do it, or they thought they knew how to do it, but they didn't know how to do it. I don't know what, well, yeah, I don't know. I don't want to overthink that. Given an integer array, find the number of triangles that can be formed with three different array elements as lengths of three sides of the triangle. A triangle with three given sides is only possible if the sum of any two sides is always greater than the third side. Add any two sides, it's got to be greater than the third side. Okay, yeah, I mean that makes sense. You know, if you took as possible triangles, like say in this example, I'm going to take 21 and 22 and then 100. Where are you going to put the 100? I mean, that just isn't gonna work. So yeah, so we can figure it out that way. Okay, yeah, like 1, 2, 3 doesn't work. You know, you've got 1, you've got 2. Where's the 3 going to go? You'd have to just lay it flat on top of the 1 and 2. That's not a triangle. Same thing here. 3, 4, 7 is not a triangle. Time complexity, n squared. That's good. Company tags, Amazon and Microsoft. Sorting, right? Good. That's good to know also, because it would be helpful to sort these. All right, well, here's what we can do. So we've got n squared to work with, so really we can do virtually a brute force algorithm on this, and that is sort the array, and then like this. We're going to sort the array. Here's our count. We have an outer loop to take the first number, and then we have an inner loop starting at I plus 1 to get the next number. We'll try out all possible numbers after the first number. And then, you know, because we have to try out triplets, it's almost like now it's going to become n cubed, and it's not going to work. That was my first thought, but you know, let's try it anyway. So we'll start with k. K will be j plus 1. Now we can take the element at index I and index j and add it, and in order to meet the definition of a triangle, the third number has to be less than that sum, which is what we have here. And then we also have a check to make sure that we don't run k past the length of the array. Now, the good thing about this is that because the array is sorted, once we hit one number where array at k is greater than or equal to sum, we can stop because none of all of the following numbers will be just as big or bigger, and they're not going to work either. So we can try that. We'll run a nested loop to get the first two numbers, and then the third number we'll just go until we get to a number that is greater than or equal to sum, and then stop. As long as it's less than sum, we have a triangle, so we can count it. We can increment k, go on to the next one. So yeah, let's submit it and see what happens. Okay, so it's the most obvious solution, and it works. The 20-something% is surprisingly low, but I don't know, maybe it was just typos or something. Anyway, that's that's it. We can use the fact that they give us this. That's useful on these. It says n squared. Normally, you don't want to do n squared on these programming challenges. It's too brute forcey, and it tends to time out. But in this case, go ahead and use n squared. So we use it and find a way to check the third number and also to pair off searches that are no longer going to be fruitful. So that's it. Please like the video, and you can subscribe to the channel. It's free. I'll send you problems of the day every weekday, and we'll see you next time.